discrete probability distribution graphs. Our objective, we want to graph discrete probability distribution. Let's remind ourselves discrete, a random variable that has either a finite or a countable number of values. Okay, let's review a couple of items that we know. We know the probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities in the form of a table, which we saw in a previous video, a graph, which we're seeing in this video, or a formula. And we know the rules for a discrete probability distribution. If P of x denotes the probability that a random variable of x equals x, then the sum of your P of x is going to be 1. The sum of all the probabilities is 1. We want everything to be represented. And the probability of every individual possibility is greater than or equal to 0 and less than or equal to 1. All right. We're going to make use of StatCrunch for this. In the graph of a discrete probability distribution, the horizontal axis represents the values of the discrete random variable. The vertical axis represents the corresponding probability of the discrete random variable. And again, we're going to use StatCrunch to do this. Example 1. In the Sullivan's Statistics Survey 1, individuals were asked to disclose the number of televisions in their household. How many TVs do you have? In the following probability distribution, which is located in StatCrunch 6.1.17, the random variable x represents the number of televisions in these households. So, looks like nobody had 0 televisions. One television was in 0.161 of the households, which as a percent is 16.1%. The number of households that had 2 televisions, the probability was 0.261. The probability of having 2 TVs was just a little over 26%. We want to graph the probability distribution. This is our horizontal axis. Okay, the values of the discrete random variable, 0 through 9. And this will be our vertical axis, the corresponding probability of the discrete random variable. We're going to graph this using Desmos. If you're interested, I won't do this as for time purposes, but if you want to copy the graph down here in this space below, help yourself. Okay, let's get to our software, StatCrunch. And I've got us here. So here's chapter 6, and there's 6.1.17. I'll select that. And here we have what we just saw in the table on the notes. What's the probability that you have 0 tables, 1 table up to, TV, let's try that again, up through 9. And these are the corresponding probabilities. There's a 0.161 probability that the household has 1 television, or 16.1% if you change that to a percent. 0 probability you have no TVs, and really just above 0, 1%, 0.01 probability that a household has 8 or 9 TVs. That's obviously quite a number of televisions. I'm trying to think. I think I only have 1, so I would be in this category right here. So how do we graph? How do we come up with the graph of the probability distribution? We're going to go to Stat, and we're going to choose down here. Whoops, where'd my Stat? Oh, I know where it is. Stat calculator. So we're going to choose the first calculators. Here's what the down here is, and then we're going to choose Custom, and that's way down here. We're going to choose Custom. Okay, so our values, in this case, the number of televisions, is right there. This is our horizontal axis. And our weights, in this case the probability, is our vertical axis, and then we'll compute it. And there you have it. Let's see if I can get it so you can see it all. I think I got you there. And you can, my iPad is not My iPad is not showing us the 1 or the 3, but 1 television. 0 TVs is here. 1 television, 2, 3, 4, etc. And you can see this is the probability distribution. There's your 0.16. Here's your 0.26. Obviously, most households, the probability of having 2 TVs is a 26% probability. So that looks like it's most people. And then this looks like it's skewed to the right. A little lower down here, we'll kind of get into this a little later. The mean is 3.21 televisions, and the standard deviation is 1.74 televisions. But there you have it, 0 through 9. Again, if you want to copy this on that paper, you're welcome to do that. But that is the graph of this discrete probability distribution.